Chapter 5, Categorical Propositions. So let's first summarize deductive arguments. A deductive argument is an argument whose premises are claimed to provide conclusive grounds for the truth of its conclusion. Validity is a characteristic of any deductive argument whose premises, if they were all true, would provide conclusive grounds for the truth of its conclusion. Such an argument is said to be valid. Classical or Aristotelian logic, the traditional account of syllogistic reasoning in which certain interpretations of categorical propositions are presupposed. Modern or modern symbolic logic, the account of syllogistic reasoning accepted today, it differs in important ways from the traditional account. Theory of deduction. We turn now to the analysis of the structure of arguments. Preceding chapters have dealt mainly with the language in which arguments are formulated. In this and succeeding chapters, we explore and explain the relations between the premises of an argument and its conclusion. All of part 2 of this book is devoted to deductive arguments. A deductive argument is one whose premises are claimed to provide conclusive grounds for the truth of its conclusion. If that claim is correct, that is, if the premises of the argument really do assure the truth of its conclusion with necessity, that deductive argument is valid. Every deductive argument either does what it claims or it does not. Therefore, every deductive argument is either valid or invalid. If it is valid, it is impossible for its premises to be true without its conclusion also being true. The theory of deduction aims to explain the relations of premises and conclusion in valid arguments. It also aims to provide techniques for the appraisal of deductive arguments, that is, for discriminating between valid and invalid deductions. To accomplish this, two large bodies of theory have been developed. The first is called classical logic or Aristotelian logic, after the Greek philosopher who initiated this study. The second is called modern logic or modern symbolic logic, developed mainly during the 19th and 20th centuries. Classical logic is the topic of this and the following two chapters. Modern symbolic logic is the topic of chapters 8, 9 and 10. Aristotle was one of the towering intellects of the ancient world. After studying for 20 years in Plato's academy, he became tutor to Alexander the Great. Later he founded his own school, the Lyceum, where he contributed substantially to nearly every field of human knowledge. His great treatises on reasoning were collected after his death and came to be called the organon, meaning literally the instrument, the fundamental tool of knowledge. The word logic did not acquire its modern meaning until the 2nd century CE, but the subject matter of logic was long understood to be the matters treated in Aristotle's seminal organon. Aristotelian logic has been the foundation of rational analysis for thousands of years. Over the course of those centuries, it has been very greatly refined. Its notation has been much improved. Its principles have been carefully formulated. Its intricate structure has been completed. This great system of classical logic set forth in this and the next two chapters remains an intellectual tool of enormous power, as beautiful as it is penetrating. The four kinds of categorical propositions. There are four and only four kinds of standard form categorical propositions. Here are examples of each of the four kinds. All politicians are liars. No politicians are liars. Some politicians are liars. Some politicians are not liars. We will examine each of these kinds in turn. Universal affirmative propositions. In these, we assert that the whole of one class is included or contained in another class. All politicians are liars is an example. It asserts that every member of one class, the class of all politicians, is a member of another class, the class of liars. Any universal affirmative proposition can be written schematically as all S is P, where the letters S and P represent the subject and predicate terms respectively. Such a proposition affirms that the relation of class inclusion holds between the two classes and says that the inclusion is complete or universal. All members of S are said to be also members of P. Propositions in this standard form are called universal affirmative propositions. They are also called A propositions. Categorical propositions are often represented with diagrams using two interlocking circles to stand for the two classes involved. These are called Venn diagrams, named after the English logician and mathematician John Venn (1834 to 1923), who invented them. Later, we will explore these diagrams more fully, and we will find that such diagrams are exceedingly helpful in appraising the validity of deductive arguments. For the present, we use the diagrams only to exhibit graphically the sense of each categorical proposition. We label one circle S for subject class and the other circle P for predicate class. The diagram for the A proposition, which asserts that all S is P, shows that portion of S which is outside of P shaded out, indicating that there are no members of S that are not members of P. So the A proposition in diagram this. Standard form categorical proposition: any categorical proposition of the form all S is P universal affirmative, or no S is P universal negative, or some S is P particular affirmative, or some S is not P particular negative. Respectively, these four types are known as A, E, I, and O propositions. Venn diagram: iconic representation of a categorical proposition or of an argument used to display their logical forms by means of overlapping circles. The second one is universal negative propositions. The second example above, no politicians are liars, is a proposition in which it is denied universally that any member of the class of politicians is a member of the class of liars. It asserts that the subject class S is wholly excluded from the predicate class P. Schematically, categorical propositions of this kind can be written as no S is P, where again S and P represent the subject and predicate terms. This kind of proposition denies the relation of inclusion between the two terms and denies it universally. It tells us that no member of S are members of P. Propositions in this standard form are called universal negative propositions. They are also called E propositions. The diagram for the E proposition will exhibit this mutual exclusion by having the overlapping portion of the two circles representing the classes S and P shaded out. The third one is particular affirmative propositions. The third example above, some politicians are liars, affirms that some members of the class of all politicians are members of the class of all liars, but it does not affirm this of politicians universally. Only some particular politician or politicians are said to be liars. This proposition does not affirm or deny anything about the class of all politicians. It makes no pronouncements about the entire class. Nor does it say that some politicians are not liars, although in some contexts it may be taken to suggest that. The literal and exact interpretation of this proposition is the assertion that the class of politicians and the class of liars have some member or members in common. That is what we understand this standard form proposition to mean. Some is an indefinite term. Does it mean at least one, at least two, or at least several? How many does it mean? Context might affect our understanding of the term as it is used in everyday speech, but logicians, for the sake of definiteness, interpret some to mean at least one. A particular affirmative proposition may be written schematically as some S is P, which says that at least one member of the class designated by the subject term S is also a member of the class designated by the subject term by the predicate term P. The proposition affirms that the relation of class inclusion holds, but does not affirm it of the first class universally. It affirms it only partially, that is, it is affirmed of some particular member or members of the first class. Propositions in this standard form are called particular affirmative propositions. They are also called I propositions. The diagram for the I proposition indicates that there is at least one member of S that is also a member of P by placing an X in the region in which the two circles overlap. The fourth one is particular negative propositions. The fourth example above, some politicians are not liars, like the third, does not refer to politicians universally but only to some member or members of that class. It is particular. Unlike the third example, however, it does not affirm the inclusion of some member or members of the first class in the second class. This is precisely what is denied. It is written schematically as some S is not P, which says that at least one member of the class designated by the subject term S is excluded from the whole of the class designated by the predicate term P. The denial is not universal. Propositions in the standard form are called particular negative propositions. They are also called O propositions. The diagram for the O proposition indicates that there is at least one member of S that is not a member of P by placing an X in the region of S that is outside of P. So the O proposition is diagrammed. The examples we have used in this section employ classes that are simply named: politicians, liars, vegetarians, athletes, and so on. But subject and predicate terms in standard form propositions can be more complicated. Thus, for example, the proposition all candidates for the position are persons of honor and integrity has the phrase candidates for the position as its subject term and phrase persons of honor and integrity as its predicate term. Subject and predicate terms can become more intricate still, but in each of the four standard forms, a relation expressed between a subject class and a predicate class. These four A, E, I, and O propositions are the building blocks of deductive arguments. This analysis of categorical propositions appears to be simple and straightforward, but the discovery of the fundamental role of these propositions and the exhibition of their relations to one another was a great step in the systematic development of logic. It was one of Aristotle's permanent contributions to human knowledge. Its apparent simplicity is deceptive. On this foundation, classes of objects and the relations among those classes, logicians have erected, over the course of centuries, a highly sophisticated system for the analysis of deductive argument. This system, whose subtlety and penetration mark it as one of the greatest of intellectual achievements, we now explore in the following three steps. In the remainder of this chapter, we will examine the features of standard form categorical propositions more deeply, explaining their relations to one another and what inferences may be drawn directly from these categorical propositions. Much of deductive reasoning can be mastered with no more than a thorough grasp of A, E, I, and O propositions and their interconnections. The next chapter will examine syllogisms, the arguments that are commonly constructed using standard form categorical propositions. We will there explore the nature of syllogisms and show that every valid syllogistic form is uniquely characterized and is therefore given its own name. We will then develop powerful techniques for determining the validity of syllogisms. In Chapter 7, we integrate syllogistic reasoning and the language of arguments in everyday life. Some limitations of reasoning based on this foundation will be identified, but the wide applicability that this foundation makes possible will be demonstrated. So, overview of standard form categorical propositions. Proposition form, all SSP. A, universal affirmative. Example, all lawyers are wealthy. Proposition form, no SSP. E proposition, universal negative. Example, no criminals are good citizens. Proposition form, some SSP. I proposition, particular affirmative, some chemicals are poisons. Proposition form, some S is not P. O proposition, particular negative, some insects are not pests. Identify the subject and predicate terms and name the form of each of the following proposition. First, some historians are extremely gifted writers whose works read like first-rate novels. Second, no athletes who have accepted pay or participating in sports are amateurs. Third, no dogs that are without pedigrees are candidates for blue ribbon in official dog shows sponsored by the American Kennel Club. Fourth, all satellites that are currently in orbit less than 10,000 miles high are very delicate devices that cost many thousands of dollars to manufacture. Fifth, some members of families that are rich and famous are not persons of either wealth or distinction. Sixth, some paintings produced by artists who are universally recognized as masters are not works of genuine merit that either are or deserve to be preserved in museums and made available to the public. Seventh, all drivers of automobiles that are not safe are desperates who threaten the lives of their fellows. Eighth, some politicians who could not be elected to the most minor positions are appointed officials in our government today. Ninth, some drugs that are very effective when properly administered are not safe remedies that all medicine cabinets should contain. 10th, no people who have not themselves done creative work in the arts are responsible critics on whose judgment we can rely. Classes and categorical propositions 5.2. Classical logic deals mainly with arguments based on the relations of classes of objects to one another. By a class, we mean a collection of all objects that have some specified characteristic in common. The concept of classes was introduced briefly in Chapter 3 in explaining definitions based on the intension of terms. Everyone can see immediately that two classes can be related in at least the following three ways. First way, all of one class may be included in all of another class. Thus, the class of all dogs is wholly included or wholly contained in the class of all mammals. Second, some but not all of the members of one class may be included in another class. Thus, the class of all athletes is partially included in the class of all females. Third, two classes may have no members in common. Thus, the class of all triangles and the class of all circles may be said to exclude one another. These three relations may be applied to classes or categories of every sort. In a deductive argument, we present propositions that state the relations between one category and some another category. The propositions with which our arguments are formulated are therefore called categorical propositions. Categorical propositions are the fundamental elements, the building blocks of argument in the classical account of deductive logic. Consider the argument. No athletes are vegetarians. All football players are athletes. Therefore, no football players are vegetarians. This argument contains three categorical propositions. We may dispute the truth of its premises, of course, but the relations of the classes expressed in these propositions yield an argument that is certainly valid. If those premises are true, that conclusion must be true. It is plain that each of the premises is indeed categorical, that is, each premise affirms or denies that some class S is included in the some other class B, in the whole or in part. In this illustrative argument that the three categorical propositions are about the class of all athletes, the class of all vegetarians, and the class of all football players. The critical first step in developing a theory of deduction based on classes, therefore, is to identify the kinds of categorical propositions and to explore the relations among them. Class, the collection of all objects that have some specified characteristic in common. Categorical proposition, a proposition that can be analyzed as being about classes or categories, affirming or denying that one class S is included in some other class B in whole or in part. Quality, quantity, and distribution. A. Quality. Every standard form categorical proposition either affirms or denies some class relation, as we have seen. If the proposition affirms some class inclusion, whether complete or partial, its quality is affirmative. So the A proposition, all SSP, and the I proposition, some SSP, are both affirmative in quality. The letter names A and I are thought to come from the Latin word affirmo, meaning I affirm. If the proposition denies class inclusion, whether complete or partial, its quality is negative. So the E proposition, no SSP, and the O proposition, some SSP, are both negative in quality. Their letter names E and O are thought to come from Latin word nego, meaning I deny. Every categorical proposition has one quality or the other, affirmative or negative. Quality, an attribute of every categorical proposition determined by whether the proposition affirms or denies class inclusion. Thus, every categorical proposition is either affirmative in quality or negative in quality. Quantity. Every standard form categorical proposition has some class as its subject. If the proposition refers to all members of the class designated by its subject term, its quantity is universal. So the A proposition, all SSP, and the E proposition, no SSP, are both universal in quantity. If the proposition refers only to some members of the class designated by its subject term, its quantity is particular. So the I proposition, some SSP, and the O proposition, some SS not P, are both particular in quantity. The quantity of a standard form categorical proposition is revealed by the word with which it begins: all, no, or some. All and no indicate that the proposition is universal. Some indicates that the proposition is particular. The word no serves also in the case of the E proposition to indicate its negative quality, as we have seen. Because every standard form categorical proposition must be either affirmative or negative and must be either universal or particular, the four names uniquely describe each one of the four standard forms by indicating its quantity and its quality. Universal affirmative A, particular affirmative I, universal negative E, particular negative O. C. General schema of standard form categorical proposition. Between the subject and predicate terms of every standard form categorical proposition occurs some form of the verb to be. This verb, accompanied by not in the case of the O proposition, serves to connect the subject and predicate terms and is called the copula. Writing the four propositions schematically as we did earlier, all SSP, some SSP, etc., only the words is and is not appear. But depending on context, other forms of the verb to be may be appropriate. We may change the tense. For example, some Roman emperors were monsters, or some soldiers will not be heroes. Or change to the plural form of the verb. For example, all squares are rectangles. In these examples, were, are, and will not be serve as copulas. However, the general skeleton of a standard form categorical proposition always consists of just four parts. First, the quantifier, then the subject term, next the copula, and finally the predicate term. The schema may be written as quantifier, subject term, copula, predicate term. D. Distribution. Categorical propositions are regarded as being about classes, the classes of objects designated by the subject and predicate terms. We have seen that a proposition may refer to classes in different ways. It may refer to all members of a class or refer to only some members of that class. Thus, the proposition all senators are citizens refers to or is about all senators, but it does not refer to all citizens. That proposition does not affirm that every citizen is a senator, but it does not deny it either. Every proposition is thus seen to refer to all members of the class designated by its subject term S, but does not refer to all members of the class designated by its predicate term P. To characterize the ways in which terms can occur in categorical propositions, we introduce the technical term distribution. A proposition distributes a term if it refers to all members of the class designated by that term. In A, E, I, and O propositions, the terms that are distributed vary as follows. In the A proposition example, all senators are citizens. In this proposition, senators is distributed but citizens is not. In A proposition, universal affirmatives, the subject term is distributed but the predicate term is undistributed. In the E proposition example, no athletes are vegetarians. The subject term athletes is distributed because the whole class of athletes is said to be excluded from the class of vegetarians. However, in asserting that the whole class of athletes is excluded from the class of vegetarians, it is also asserted that the whole class of vegetarians is excluded from the class of athletes. Of each and every vegetarian, the proposition says that he or she is not an athlete. Unlike an A proposition, therefore, an E proposition refers to all members of the class designated by its predicate term and therefore also distributes its predicate term. E propositions, universal negative, distribute both their subject and predicate terms. In the I proposition, some soldiers are cowards. No assertion is made about all soldiers in this proposition, and no assertion is made about all cowards either. It says nothing about each and every soldier and nothing about each and every coward. Neither class is wholly included or wholly excluded from the other. In I propositions, particular affirmatives, both subject and predicate terms are undistributed. In the O proposition example, some horses are not thoroughbreds. Nothing is said about all horses. The proposition refers to some members of the class designated by the subject term. It says of this part of the class of horses that is excluded from the class of all thoroughbreds, but they are excluded from the whole of the latter class. Given the particular horses referred to, the proposition says that each and every member of the class of thoroughbreds is not one of those particular horses. When something is said to be excluded from a class, the whole of the class is referred to, just as when a person is excluded from a country, all parts of that country are forbidden to that person. In no propositions, particular negatives, the subject term is not distributed, but the predicate term is distributed. We thus see that universal propositions, both affirmative and negative, distribute their subject terms, whereas particular propositions, whether affirmative or negative, do not distribute their subject terms. Thus, the quantity of any standard form categorical proposition determines whether its subject term is distributed or undistributed. We likewise see that affirmative propositions, whether universal or particular, do not distribute their predicate terms, whereas negative propositions, both universal and particular, do distribute their predicate terms. Thus, the quality of a standard form categorical proposition determines whether its predicate term is distributed or undistributed. In summary, the A proposition distributes only its subject term. The E proposition distributes both its subject and predicate terms. The I proposition distributes neither its subject nor its predicate term, and the O proposition distributes only its predicate term. Which terms are distributed by which standard form categorical propositions will become very important when we turn to the evaluation of syllogisms. The following diagram presents all those distributions graphically and may be useful in helping you to remember which propositions distribute which of their terms. In A, all SSP, subject term distributed, predicate term not distributed. In E, no SSP, predicate term distributed, subject term distributed. In I, some SSP, subject term is not distributed, predicate term is also not distributed. In O, some S is not P, predicate term is distributed and subject term is not distributed. So let's have a quick summary. What is quantity? An attribute of every categorical proposition determined by whether the proposition refers to all members or only to some members of the class designated by its subject term. Thus, every categorical proposition is either universal in quantity or particular in quantity. Copula, any form of the verb to be that serves to connect the subject term and the predicate term of a categorical proposition. Distribution, an attribute that describes the relationship between a categorical proposition and each one of its terms, indicating whether or not the proposition makes a statement about every member of the class represented by a given term. Visual logic. The A proposition, all bananas are fruits. This A proposition asserts that every member of the class of bananas, the subject class, is also a member of the class of fruits, the predicate class. When a term refers to every member of a class, we say that the term is distributed. In an A proposition, the subject term is always distributed, but the A proposition does not refer to every member of the predicate class. This example does not assert that all fruits are bananas. It says nothing about every fruit. In an A proposition, the predicate term is not distributed. The E proposition, no bananas are fruits. This E proposition asserts that every member of the class of bananas is outside the class of fruits. The subject term bananas is plainly distributed. Because bananas are excluded from the entire class of fruits, this proposition refers to every member of the predicate class as well, because it plainly says that no fruit is a banana. In an E proposition, both the subject term and the predicate term are distributed. Note that the concept of distribution has nothing to do with trust or falsity. This example proposition is certainly false, but as in every E proposition, both of its terms are distributed. The I proposition, some bananas are fruits. The word some in this proposition tells us that at least one member of the class designated by the subject term bananas is also a member of the class designated by the predicate term fruits, but this proposition makes no claim about the subject class as a whole. Therefore, in this proposition, as in every I proposition, the subject term is not distributed, nor does this proposition say anything about every member of the class of fruits. We are told that there is at least one member of the class of bananas in it, so the predicate is not distributed either. In an I proposition, neither the subject term nor the predicate term is distributed. The O proposition, some bananas are not fruits. The word some again tells us that this proposition is not about all members of the class of bananas. The subject term is therefore not distributed. Because we are told in this proposition that some bananas are not fruits, we are told that something about the entire predicate class, namely that the entire class of fruits does not have one of those subject bananas among them. In an O proposition, the predicate term is distributed, but the subject term is not distributed. We conclude this section with a table that represents all the critical information about each one of the four standard form categorical propositions. So the proposition all is P, letter name is A proposition, quantity universal, quality affirmative, and only distributes the subject. The proposition no S is P, letter name E proposition, quantity is universal, quality is negative, and distributes both the subject and predicate. The third is some S is P, letter name is I proposition, quantity is particular, quality is affirmative, and neither distributes subject nor the predicate. The fourth is some S is not P, letter name is O proposition, quantity is particular, quality is negative, and only distributes the predicate term. Exercises. Name the quality and quantity of each of the following propositions and state whether their subject and predicate terms are distributed or undistributed. First, some presidential candidates will be sadly disappointed people. Second, all those who died in Nazi concentration camps were victims of a cruel and irrational tyranny. Third, some recently identified unstable elements were not entirely accidental discoveries. Fourth, some members of the military-industrial complex are mild-mannered people to whom violence is abhorrent. Fifth, no leader of the feminist movement is a major business executive. Sixth, all hard-line advocates of law and order at any cost are people who will be remembered, if at all, only for having failed to understand the major social pressures of the 21st century. Seventh, some recent rulings of the Supreme Court were politically motivated decisions that flouted the entire history of US legal practice. Eighth, no harmful pesticides or chemical defoliants were genuine contributions to the long-range agricultural goals of the nation. Ninth, some advocates of major political, social, and economic reforms are not responsible people who have a stake in maintaining the status quo. 10th, all new labor-saving devices are major threats to the trade union movement. The traditional square of opposition. The preceding analysis of categorical proposition enables us to exhibit the relations among those propositions, which in turn provide solid grounds for a great deal of the reasoning we do in everyday life. We need one more technical term, opposition. Standard form categorical propositions having the same subject terms and the same predicate terms may obviously differ from each other in quality or in quantity or in both. Any such kind of differing has been traditionally called opposition. This term is used even when